So you got your expensive graphics card, your overclocked octa-core CPU, and more memory than a frickin' elephant, but when you're playing the latest AAA games on your PC or really anything else, for some reason things don't seem quite right, especially when you're looking at a scene where a lot of things are moving around at once or the camera's panning. Because even with all that horsepower under the hood, motion blur is a problem on even the most powerful rigs. And if you're gaming on a VR headset like the Oculus Rift, it can be even more distracting. Now, to be clear, we're not talking about the kind of motion blur that is intentionally added to a game in post-processing. What we're talking about is unintentional motion blur caused by excessive pixel persistence. You see, an electronic display, whether it's a computer monitor or a headset or a phone, is made up of millions of individual pixels that change their brightness and color to create an image that you see. So whenever the image on the screen changes, which is nearly constantly if you're playing a game that isn't Pong, the pixels cannot respond instantaneously. With a typical LCD monitor, there's actually a delay of a few milliseconds before the pixels can actually change. Now, while there are fast response monitors which have a delay or response time of just 1 or 2 milliseconds, which helps to cut down on motion blur significantly, even those don't completely solve the problem. In fact, even if a 0 millisecond monitor existed, there's still an issue with how LCD displays actually show images to us. Like other pieces of digital hardware, an LCD display works by sampling image data it gets from the computer many times a second and displaying the samples as a series of still images. These still images are then displayed at a rate equal to your screen's refresh rate, usually 60 Hz, and your brain interprets this as movement. However, your eye is not a piece of computer hardware, unless of course your name is Adam Jensen. Human eyes are really good at perceiving differences in fluid motion, and while high refresh rate displays that operate at 144 Hz or even higher look great, they still can't completely fool our brains just by showing us a series of static images. And as if the problem of motion blur weren't bad enough on computer monitors, it's much worse if you're using an Oculus Rift or VR headset, like I mentioned before. While motion blur might just be an annoyance if you're gaming in 2D on a desktop PC, it can actually make you sick on a 3D display like the Oculus Rift. Because these headsets work by surrounding your field of vision in immersive 3D environments, motion blur in these situations can make you feel physically out of balance with your surroundings and cause a very similar nausea to what you'd feel in a car or an airplane in the same situation. So the solution itself is a pretty simple idea. Well, let's just cut down on how long individual pixels are displayed so that we're not out of sync. But how are display manufacturers going to accomplish this? Well, one way is through a technique called backlight strobing. Typically, modern LCD monitors are illuminated by a backlight that's always on. However, in a display that uses backlight strobing, the backlight instead switches on and off rapidly, reducing the amount of time that you actually see each pixel. This is very similar to the way that CRT displays, which were, for the kids that weren't alive in the time of the dinosaurs, which are those old tube things that existed before LCDs came onto the market, and is the reason that CRTs have historically been better at displaying scenes with fast motion, at least to our eyes. There are a number of monitors on the market that feature backlight strobing combined with high refresh rates to reduce motion blur as much as possible while still maintaining the picture quality and low energy consumption, not to mention the space savings, of a flat panel LCD. Of course, it's also possible to ditch the backlight altogether and go a different route. So the consumer version of the Oculus Rift features a display based on organic LEDs, or OLEDs. OLEDs can generate their own light through the use of specialized organic compounds. But more importantly for gamers, OLEDs have a very quick response time, much faster than the pixels in a conventional LCD, and not only does this cut down on motion blur on its own, the low response times allow OLEDs to interpolate frames easily, meaning that your system FPS, missing frames in a given second to match your display's frame rate. Or if you're just watching a movie recorded at the usual 24 FPS and you want your experience to be less cinematic, I guess it could do that too. So whether you're gaming in 3D using a headset or just a monitor with 3D glasses, these technologies will help you do your thing without feeling like you're on some kind of vomit-inducing carnival ride. Speaking of vomit-inducing carnival rides, our sponsor today is Fractal Design, and boy do we have a treat for you. Instead of telling you guys about their, Scandinavian-designed cases and power supplies and cooling products, we're having Luke wrap me up and take... Look, we had this conversation already. I told you I have to host this because you just can't do a good enough job of it. So
I'm super done. I'm sick. This is ridiculous. I've been trying to build this company for like 2 years.
Okay, we don't have to roll the camera on this. Okay, look, if you need to talk about this, then...
You need to talk to yourself about how you run the company. No air conditioning. People are like overheating all the time. I'm working while I'm sick. I have to just get my doctor's appointment because I have to tape you up.
Look, I think
What even is that? Like, I've been sick for like 2 months. I finally get a doctor's appointment with my family doctor.
Okay,
and you make me not go because of masking tape?
Well, look, okay, but we were supposed to have you do the spot, and you were supposed to do Josh's thing. I get dragged into the office, and I have to film this. It's not like I wanted to. Okay, you know what,
I'm done.
We'll talk later.
No, I'm just done. You.
So, sorry, I hope that wasn't too awkward. Guys, like the video if you liked it, dislike it if you disliked it, leave a comment. If you have suggestions for future Fast as Possibles that I guess won't be hosted by Luke. And as always, don't forget to subscribe.